Hello everyone, welcome to RoboMaster 101. I'm Steven.
I'm Justin.
So this would be our first episode of RoboMaster 101. In this episode of video, we're trying to help all the team from North America who are going to participate in the RoboMaster competition to help you guys have a better understanding of the competition rule, of the competition itself, and also we will cover the most important material here is about how to do not just mechanical part of the robot, but also how to do the embedded system part of the robot and how to do computer vision part of the robot. So today we're going to start with the most basic concept of the robot, which is the chassis. So let's use this small RoboMaster S1 as an example. So in RoboMaster competition, there's one thing pretty unique is that we have something called mechanism wheel. So you can see all the robots, they don't have a steering wheel system, so they don't turn like a normal car, but actually they're able to move not just forward, backward, but also left and right, side by side. So how is this function got fulfilled?
The wheels, when they go forward and backward, it functions as much like a regular track wheel, but when it's trying to go sideways, the front and back wheels rotate one clockwise and one counterclockwise to result in horizontal force.
Yeah, so which means the wheel itself is quite unique that it's a huge wheel that composed or combined with small roller that is located 45 degrees. So when it's rotate, it actually provides a force that is horizontally and another force that is vertically. So when two wheels that is rotate in a different direction, one direction of the force will be cancelled out and it will be able to move side by side like this.
It's also important to remember that when you install the mechanism wheels, the rollers need to all point to the center to form an X shape.
That's when you have when you see the robot from the top wheel. So from top to bottom, the four mechanism wheel should be like an X. So Justin, we mentioned that in order to let the robot move side by side, the mechanism will have to turn different direction. So this is a motor we use for the RoboMaster competition, the M3508. So what's the special of this kind of motor? What's the different, different from the all kinds of brushless motor online?
This motor have an encoder built into it. We can know exactly where the motor is at any moment of the time. That means we can precisely control where the motor is at and its speed or acceleration and all the data from it.
So next, let's move on from the RoboMaster S1, the small robot, to the real robot that we're going to use during the competition. So this is an infantry robot that Team RoboGrinder from Virginia Tech was using in 2018's RoboMaster competition. We're going to use this robot to show you guys how to do the embedded system part on tuning a chassis. So Justin, I remember you mentioned that we need a ESC for the RM3508 motor. So how we actually connect this ESC to the motor?
The 8-pin is to read the encoder value back to the ESC and then send back over to the development board. To connect the motor to the electronic speed controller, we need to connect the 3-pin power cable that you match the color on both sides and also the signal cable to the electronic speed controller, like that, and it should work. If your motor does not run properly, sometimes you also need to check on those two connections.
So these are the stuff we need for today's tutorial. The first is the M3508 brushless DC motor. The next one is a C620 ESC. Then is the RoboMaster Type A development board. Then we also need a receiver, a debugger, a controller, and a battery. So for control the motor and also all the electronic device you're going to use on this robot, we're using this type of development board. So for today's tutorial, we're gonna use this 4 XT30 port 24 volts power supply, and also 1, 2, 3, 4, 5, 6. This is 6 CAN bus port for running the motor. So how to put all these things together?
We need to connect the electronic speed controller, connect its power to the board, and the CAN bus cable to one of the 6 ports, like this. For one of the ESC, we also have 3 more to connect to the rest of the 3 pairs.
So after that, all the ESC is connected to the board. The next step is how are you able to let the board know what you want the board to do. To let the board receive our command, we also need this DR16 receiver. So for the development board, there's only one port that you can connect the receiver to, which is this one, the D bus. When connect the receiver to the board using this 3-pin cable, and you have to make sure the ground is matched with the ground on the receiver. So the gray wire is the ground, you connect it like this, then the receiver is already connected with the board. So every time when you got a new receiver, you have to pair it with a controller. Next step, we're gonna show you guys how to do that. So first step, you have to power up the board. So these several ports that is called XT30 with 2 pins, they are all power port. These 3 provide 12 volts power supply. These 4 provide 24 volts power supply. And this one here in yellow color is where you're gonna power up this board. So let's use this DJI TB47 battery to power up this board. As a small hint for all the teams that are going to participate in the RoboMaster competition, right now we're only allowed to use DJI's official battery because of safety requirements during the competition. So any other type of lithium or lipo battery, you may use it during, when you develop the robot, when you tuning the robot, but during the competition, this type of battery is the only allowed battery. So let's connect this cable with the board. Then the next step is turn on the battery. You hold it, then it's on. So next step, you will see the DR16 receiver is in red. Sometimes it will in flash green, which means you need to pair it with a controller. So the function, how the pair function work is every time you let the receiver go into pair mode, it will automatically pair with the controller that has the strongest signal. Normally is the one that is the closest to it. So you use a small pin like this, and here is the button. You hold it for like 3 seconds. When you see it's flashing red, you turn on the controller. If the DR16 receiver turns green, which means it's already paired with the controller. To verify that this receiver is paired with the controller you want, just simply turn off the controller like this. Then the receiver should back to a red light. Then I turn it on again. The receiver turns green, which means they're paired. So next step would be download the code we need into the development board. So now we're gonna show you guys how to actually download the code into the development board.
In order to download the code onto this development board, we need to use this port right next to the receiver port. We can download it through a cable that should came with the development board, which is this cable. You just simply connect it. And on the other side, you should use a debugger. In our case, we're using a J-Link. However, you can also use ST-Link or other kind of debugger that you like. To download the code, we're using a SW protocol, which require 4 pins. And on this J-Link, we have this little gadget that help us connect the 4 pins to the pins on the J-Link. You can find the pins assignment for SW protocol for J-Link on this picture. So you need to connect the VCC, SWDIO, SW clock, and ground. Exactly match it onto the board. Now let's move to the coding part of the development board. The sample code for ICRA competition is provided by RoboMaster's official website, which is very helpful. We will put the GitHub link down in the description. There are 3 branches on this GitHub repository. We will be using the ICRA 2019 because the ICRA 2020 branch is using the new development board type C. However, we have no such board on our hand to test the code. So once you open up the project file located in mdk-arm, this file with Keil, K-E-I-L, you should see this screen. This code is built to be robust, so it has many initialization checks. However, today we're not using all the functions. We need to bypass those initialization checks. An easy but non-standard way we can achieve this is to trick the check by going to the offline check file located under Application. On line 86, you can see this function. We can go to the definition of the function. Sometimes it will not let you do that is because you need to build the file first. Once you come here, you can see that on line 88 and line 102, line 102 is the successful case. So I just simply copy this line and replace it to the line 88. It should always have a successful check. And then, because this code is for ICRA, not necessarily for this competition, it has a chassis mode and a gimbal mode. By default, it reads a pin on the board. However, we can save the effort by simply go to the init file under Application, and on line 54, you can see this parameter is reading from a pin. We can simply set it to a static value, chassis app. It's been used many times, for example, over here on line 118. It's enabling the chassis task. So by doing that, we don't have to short a pin on our board. This should be all the changes we need to run the chassis. We will post the modified code to our GitHub and link down in the description. Next, let's download the code onto the board. There are 2 things we need to keep in check. One is the device. We need to make sure that it matches our development board. The chip we're using is STM32F427H. And the other one is debug. You need to make sure that the debugger is set to the one that you're using. In my case, it's a J-Link. Sometimes it's a ST-Link. Then we need to go to the settings. You select the port to be SW. It will automatically detect your board. Right now, my board is not powered, so it's not detecting. If I power my board up and come back to the setting, you should see the devices showing up here. Once those are done, you can simply build your project and download your code. Now the code is downloaded onto your board. We can test it on our actual chassis.
So right now, the code that for running the chassis is already downloaded in the board. Next step is you connected the 4 electric speed controller to the CAN bus and also to the power supply. Here we have a small hint or notice for you guys is that please keep in mind these 3 ports are 12 volts, these 4 are 24 volts. The size and the out shape of the port are exactly the same. But when you are using a different ESC or other type of electronics, please make sure to check the voltage before you plug them in. And also, you can see these 2-pin port have a H and L mark on it, which means CAN high and CAN low. But this one here, marked as S and G, they look exactly the same as this 6 port, but they are not CAN bus port. These 6 are the only 6 CAN bus port on it. You can connect these 4 ESC to either for all of these 6. So next step is we will cover this information in later tutorial, but CAN bus communication have an ID for each device that is using CAN bus. So we have to assign ID to each ESC. So for doing that, you can see on the ESC itself, it have a switch here and also the set button here. So for switch, this is a CAN bus resistor. In this case, we don't have to care if it's on or off. That won't influence the code or the performance at all. So for giving this 4 motor ID, the ESC itself have a function can automatically assign ID to each motor. So to perform that, use a small pin. See this here? You push it once, release, and hold it. All of them should be in yellow. Now you have to follow the sequence 1, 2, 3, 4. Turn this 4 wheel at 1 at each time. So this one first, just turn it. The degree doesn't matter, just turn it. This one will be blue for a sec, then it's flashing green. The time that is flash indicate what's the ID of it. So this one is ID 1. Let's turn this one. So now it's flashing twice, it's ID 2. Turn this one, flashing 3 times, ID 3. And this one, 4. Now, the 4 ESC on this robot is already tuned ready. The next step is turn on your controller and to test if the code is correct. But here we have another small hint for you guys is every time when you download a code to your robot, make sure 4 wheel or any wheel shouldn't touch the ground. In case something wrong with your code, the robot may drive crazy and hurting people. So next step is let's see if the code is working properly. So as you can see right now, the motor can follow the command from the controller. So for today's tutorial, right now, you can actually control the wheel.
That's all we have covered today.
So this is the really first episode of RoboMaster 101. Please leave your comment if you have any idea about this channel, if you have any advice, just leave a comment and please don't forget to hit like and subscribe. So this would be not only about embedded system. If you want us to cover, for example, how to design a good chassis or how to make a good auto-aiming algorithm like computer vision part, just leave a comment or send us a message and we will try our best to show you guys what we know about RoboMaster. Thank you.